This lesson deals with significant digit rules. You can either copy notes from this screencast or print out the PowerPoint slides found under the resource page on our class pages and add to the notes from there. So what do we mean by significant digits? We want to look at the numbers that were actually measured in order to reflect the precision of the tool. So our first rule, any number that isn't 0 means it was measured. So each of these examples have 3 significant digits. So the problem is when the zeros show up in a measurement. The rest of the rules are a reflection of the different spots 0 will be and how we count them for significant digits. First case is if zeros are between non-zero numbers. In other words, the first and the last number aren't 0. Everything was measured. All numbers are significant. So each of these examples have 4 significant digits. What about zeros in front of non-zero numbers? In other words, preceding zeros. In that case, nothing counts until a non-zero number is found. Each of the examples shown here have 2 significant digits. Let's try one on your own. How many significant digits in this example? I look, find my first non-zero number, and correctly respond 4. Our next rule deals with zeros at the end of a number if we have a decimal present. Each of these, 43.00, 1.01, in each case there is a decimal present, and so once I have a non-zero number, everything that follows is significant. These all have 4. 300 point meters, there is a decimal present, so I have 3 significant digits. 5,000 point, the decimal is present, I have 4 significant digits. What about zeros at the end when we have an understood decimal point? Here they only serve as placeholders. There is no decimal shown. So if 300 is written without a decimal and 7,000, no decimal, we have 1 measured or significant digit. In the first example, it is implying that the uncertainty would be plus or minus 100 meters. In 7,000, the way the number is written, the uncertainty would be plus or minus 1,000 meters. Notice what happens when we add a decimal point. The 300 point now goes back to the previous rule and would have 3 significant digits. 7,000 point would have 4 significant digits. How about this? No decimal present, so we have 4 significant digits. What if we put the decimal point? How many significant digits would it have then? Correct, 5. So the presence or absence of a decimal point can lead to confusion. For this reason, it is very often accepted to write answers in scientific notation, because the placeholder zeros are tied up in the coefficient. When looking at significant digits for a number in scientific notation, I only look at the coefficient. So 7.1 times 10 to the minus 3 has 2 significant digits. 4.52 times 10 to the 14th has 3. The exponent has nothing to do with it, just the coefficient. 7.10 times 10 to the minus 3 would have 3 significant digits because I'm only looking at the coefficient. Sometimes we are forced to use scientific notation to show how many significant digits. For example, 300 meters with no decimal would only have 1 significant digit. The uncertainty as written is plus or minus 100 meters. What if the 3 and the first 0 were both measured? In other words, the uncertainty is plus or minus 10 meters. The only way I could write that to show 2 significant digits would be to put it in scientific notation, because I can write the coefficient as 3.0 times 10 to the second. 3.00 times 10 to the second would show 3 significant digits, as would putting a decimal point at the end of the 300. Our final significant digit rule has to do with counting numbers and defined quantities. They are exact, they are not measurements, and therefore we say that they have an infinite number of significant digits. 58 cars, 40 test tubes are not measurements, they're counting numbers. So they would have infinite significant digits. An example of a defined quantity: 60 minutes equal an hour, 100 centimeters equal a meter. These are exacts. They are not measurements. They have an infinite number of significant digits. Let's try some examples together. 7.6003 grams. The first and last number are not 0, so everything in between, including the zeros, was measured, 5 significant digits. Our next example. We have a bunch of preceding zeros, so nothing counts until we come to the first non-zero number, giving us 3 significant digits. How about if we add a 0 at the end of that number? Again, the preceding zeros do not count. They were not measured until we hit the 4, but then everything that follows was measured for 4 significant digits. 60 with no decimal point, 1 significant digit. 60 point would have 2 significant digits. Now, you try these in your notebook for tomorrow on your own. Complete these 7 problems in your notebook for tomorrow.